Hello, algebra scholars, and welcome back to our lesson. This is chapter 9, section 6 on the quadratic formula. So we have been working so hard on figuring out ways of solving quadratic equations. So far, we've learned, and I've listed them here, to solve quadratic equations by factoring. That includes finding a greatest common factor, factoring by grouping, factoring trinomials. I didn't include this one, but we've solved quadratic equations by taking the square root. We have solved quadratics by completing the square, which was that big process we just worked on. And we've solved it by simply graphing. Now we are going to learn a final method that consistently works to solve any quadratic equation, and it's called the quadratic formula. Now, a lot of you are going to ask, Mr. Gibbs, why didn't you just teach us this to start with, and we just use this every time, since this is the thing that works always for us. And so does completing the square. Well, I'm going to say it's because there's a bunch of reasons. First of the reasons, there's a lot of opportunities to make mistakes in this. And if we can just simply factor something, once you learn how to factor well, you're unlikely to make a mistake. The second thing is that we want to be able to get our equations in certain forms. We want to be able to take them from the standard form into factored form. Well, the only way to get from standard form to factored form is to be able to factor. We want to be able to get our standard form to vertex form. Well, the only way to do that is by knowing how to complete the square. Okay? And we want to be able to see our solutions where it hits the x-axis. So we also need to be able to graph these quadratic functions. So there's a time and a place for each of these strategies. But when factoring doesn't work, when graphing's not practical, when you can't take the square root on both sides of the equation, then we are going to pull out this quadratic formula because our solution is probably much more complicated, although this will work for every quadratic equation that you could possibly be given. So let's take a look at some examples. This is obviously referring back to this equation right here, where we have an a x squared plus some b x plus some c. So this only works if we have an equation written in standard form, okay? And we need to make sure it's written in this standard form. We're still using the zero product property, so it's gotta equal 0. And if we've got that, then we can use this. And all we're doing is we're grabbing these numbers and we're putting them into this equation. Next week, I'm gonna show you how we got this equation. Where did this come from? What is this equation? And I love that lesson, but you're probably going to hate it, but it'll be okay. But where did this come from? I'll show you next week. Right now, I just want you to be able to use it, okay? So let's take a look at this. We've got an a x squared plus some bx minus c equals 0. Okay, so we've got the zero product property. This is already set up. So all I need you to do is, and I'm going to say I always write this down first, okay? You're going to make mistakes if you try to plug this into your calculator right away. I would write down all of this before you get out your calculator and plug it in. So we need a negative b. So this is a positive 5, so it's going to be negative 5 plus or minus, we always have the possibility of two solutions in a quadratic equation. So plus or minus the square root of b, well, that's 5. I always put this in parentheses, whether it's positive or negative. That just helps me to make sure I put it in my calculator correctly. Because if this is a negative number, then there's a lot of chances for us to make mistakes there. Minus 4 times a, Well, A is 3 times C, well, that's negative 7. All divided by 2 times A, which is 3. Okay, so pause real quick. Make sure you understand where all these numbers came from. Negative B, negative 5, plus or minus B squared minus, this is always a 4, A, C, divided by 2 times A. Now you can take your calculator and just plug this in, just how you see it. Or you can take a moment and simplify this thing. That is up to you, how you want to do it. I think it's sometimes helpful to see what is inside of here. So I am going to simplify it just a little bit. One thing about plugging it into the calculators right away is that sometimes, especially different calculators, are going to give you different solutions. So if you're going to plug into the calculator right away, I would just at least only do this part, okay, and see what you get. But make sure you plug in exactly what you see here, okay? But we don't need a calculator for this. We're going to do x equals negative 5 plus or minus the square root of, what is this? 5 times 5 is 25. This is going to be a negative times a negative, so that's going to be a positive. And 4 times 3 times 7. So if you want to plug that into your calculator, you can, or you can do some scratch paper off to the side. But at least do this first, okay, before you plug this whole thing into the calculator, because this might be as exact as we can get for this solution. This might be how we want to write this solution. So if I'm plugging into my calculator, though, I'm gonna use parentheses. I'm gonna put a squared in. Now, if you don't have a graphing or a scientific calculator at home, feel free to pull one up online. You just type into the Google scientific calculator, and it'll give you one. And then we have minus 4 times 3 times negative 7. Notice how I just used parentheses to represent my multiplication. If you type it exactly as you see it on your paper, you're not going to make a mistake, okay? But if we accidentally type this incorrectly, then we're going to get something we don't want. Okay, 109. Well, I just found out, and then 2 times 3 is 6. I just found out that this wasn't factorable, right? Because the square root of 109 is not a perfect square. And that maybe is even as simplified as I can get. It is, okay? So I'm going to say that this is as simple as we can write this solution. Now, if we want to, we can take this and we can come up with a decimal approximation, but this is exact. And there are two solutions, right? Negative 5 plus the square root of 109 divided by 6, and negative 5 minus the square root of 109 divided by 6. So this is our exact solution. If we want to, or if you have a certain problem that's like, I want to know approximately where the solution is located, I want to know approximately where we're hitting the x-axis, then we can plug this into a calculator and say, well, where does this live? So I'm going to show you that real quick. I'm going to use the fraction button to start, and I'm going to do my negative 5 plus, I've got to pick one of these, so I'm going to start with the plus sign, plus the square root of 109. And every calculator is slightly different on how you do this all, but they're all similar in a way, okay? So you just need to find one that works for you. And I'm going to push the equal sign. And then Our calculators at school have a little arrow button down here that lets you change from exact solution. So this is showing me right now, hey, this is the only way to represent your solution that you're looking for exactly. And we already knew that, right? But my calculator right here has a button that allows me to go from the exact answer to a decimal approximation. So we're going to say that my solution, my x, equals approximately 0.9, let's just say 0.91. We'll round it off at the hundredths place. And then to save yourself some time, if you're looking for the other solution, use some kind of, there's always some way to get back into it. Mine is to push the over button here. And then you can take away that plus sign, and now we're just putting a minus sign. So we did the plus sign. Now we're checking out what we get with this negative sign. And we see here's the exact answer. They changed this, how to write this ever so slightly by pulling out a negative, factoring out a negative, but same thing as what we wrote up here. But I want to know what it approximately is, and it's approximately negative 2.57. So here's our exact answer, and approximately this is where those solutions are located. Okay, let's do the next one. A big note, set equal to 0 first. This is not set equal to 0. The quadratic formula, everything we're doing basically does not work until we use the zero product property, okay? Until we set it equal to 0. So that's the first thing that we need to do. We need to do 2x squared. How do I get rid of a positive 2x? I subtract it. So I'm going to have minus 2x plus 3 equals 0. I always like to write it in standard form. You should always write it in standard form because we need to see this ax squared plus bx plus c in order to use the quadratic formula. So now we're going to write x equals, we need a negative b. Well, what is negative 2? It's positive 2, right? So we're going to say that this is positive 2 plus or minus the square root of b squared. Well, that's negative 2 squared. It's really important you put this in parentheses, because if you put into your calculator 2 squared with a negative sign out front, you're going to get negative 4, but this is negative 2 times negative 2, which is positive 4, okay? Parentheses is really important. Minus 4, I'm just plugging in exactly what I see. A, well, that's a 2. C, well, that's a 3. All divided by 2a. So 2 times my a, which is 2. X equals 2 plus or minus the square root of 4 minus, this is going to be problematic, isn't it? Check this out. If I plug this into my calculator, exactly how I see it, I'm right here. If I put parentheses, negative 2 squared minus 4 times 2 times 3, which side is bigger? Is this bigger or is this bigger? I hope you're saying, well, this side's bigger, Mr. Gibbs, so I'm going to get a negative number, right? And I get negative 20 divided by 2 times 2 is 4. I don't know why I made this line so big. Okay, I've got 2 plus or minus the square root of negative 20 divided by 4. Well, I'm going to tell you that you can't take the square root of a negative number, okay? So we can already say that there are no real solutions. okay? And if you want to this year just be done with that at that point, you can. But we can move on a little bit further because we have this idea of an imaginary number, which you're going to really explore next year. But basically, to simplify the whole idea, if you've got a negative inside a square root, you can get rid of that negative by writing an I out front, okay? And it's going to give us an imaginary solution, but that's okay. We can also simplify this by saying that this is 4 times 5, right? 4 times 5, that gives me 4, or it gives me 2 square roots of 5, if you remember that, that lesson, because that would be, I'm going to write this up here, you don't have to write this, the square root of 4 times 5, the square root of 4 times 5, that's 20, right? Is equivalent to the square root of 4 times the square root of 5. We can break those up. We can pass a square root over a multiplication symbol. And then we all know that the square root of 4 is 2. So here's a big leap. And if you're not with me on this leap, that's okay. You don't have to be with me on this leap right now. But we can rewrite this as 2 plus or minus, what do we say? This is 2, and to get rid of this negative sign, we're going to just put in I, meaning this is an imaginary number, friends, but we can still do this with a little mathematical magic. Square roots of 5 all over 4. Now, most of you are going to say, oh my gosh, Mr. Gibbs, that was too much. But what if I said there's more, right? Because I see that 2 divided by 4 is 1/2, right? 2 divided by 4 is 1/2. We could like factor out a 2 here, and we can rewrite this a little bit more. So I'm going to do that. If you don't like this, again, you can say whatever, Mr. Gibbs, but we could even simplify it just a little bit more to that. But I need you to be able to get to here, right? No real solutions if there is a negative sign out in front, okay? So those are 2 examples of using the quadratic formula. Now, sometimes we need to be able to use it in an application problem. This says data was gathered for a particular model of a car. The driver maintained a certain speed on a closed course of 30 minutes, and the fuel efficiency was recorded in miles per gallon. So they did like 5 trials here, and then they used a computer program to give them this quadratic that best represents their data points, right? And they came up with this crazy thing. Now, you can't try to factor this, right? Like, that's just not going to work. So what's the only way that we can do this is we can use the quadratic formula, right? And so we can use this crazy thing again, and mine's going to be off the screen, but we can say that x is going to equal negative whatever b is. Well, that's 0.9851 plus or minus the square root of b squared minus 4 times a, negative 0.0112, times c, 3.14, all divided by 2a. In this case, where the numbers are so crazy, we are not going to try to do this and then do this. What you're going to do is you're just going to take this whole thing and you are going to plug it into your calculator and see what you get, okay? And we're not even going to do that. This is the solution. plugging into the calculator is just simplifying and simplifying it some more. What do these solutions represent? And again, we need to be able to think about this. It's always where we hit the x-axis. That is all we're trying to find. In this case, we're asking, where am I going to be doing 0 miles per gallon? When does my system, in this case, break down? What is my speed limit here? Let's write, when will we use 0 miles per gallon? Okay. When will we be doing 0 miles per gallon? Basically, it looks like we're going to be here at 0, 0, right? And then at some point, we just can't increase the speed anymore. We can't measure it anymore. Okay. I am going to go ahead and do the next page on a separate video because it is a bit of a separate idea. And you can let me know if you have any questions about this side.